So the last video got cut off. So I was talking about scientific notation, and I was going to give you an example. If we have, let's say, this is 83, 69,300,000, and we want to turn that into scientific notation, right? What we're going to do is the decimal point is here. So we want that A to be between 1 and 10. It can be equal to 1, but not equal to 10. So it's 1, 2, 3, 4, 5, 6, 7, right? 6.93 is between 1 and 10. So what we're going to do is 6.93 times 10 to the, how many times did I move the decimal point? 1, 2, 3, 4, 5, 6, 7. So 7. Okay. And then vice versa, or another example, this is the other way around. If I have number 85 in your book, 3.19 times 10 to the 5th power. What number is that? What I'm going to do is I'm going to put 3.19, and I'm just going to move this decimal place over 5 times to the right. 1, 2, 3, 4, 5. So that number, and if we fill out zeros for the spaces where they don't have any numbers, it will be 319,000. So 319,000. Okay. The next part we have to go over is the property of roots. Okay, it's square roots. It's any root. Okay, so n is the numbered root, cube root, square root, fourth root. If I have n square root of ab, we can split up the a and the b and just put it in their own root. Okay, that's rule number 1. Rule number 2 is if we have some type of division, we can split up the roots as well. So if we can simplify, let's say it's cube root of 8/3, right? Then we can go cube root of 8 over cube root of 3. And the cube root of 8, if you guys know, it's 2. So it's 2 cube root of 3, and then you have to rationalize the denominator. I did not go over that. I'm not going to go over that in the lesson, but you guys should know that in your previous classes. So if we have 2 roots, cube root of m, or not cube root, m root, n root, a, we're going to multiply the roots. Okay. All right. So that's rule number 3. And then rule number 4 is this guy. Okay. N root of a to the n power is just a if it's odd. N root of a to the n power is the absolute value. It's always positive if n is even. All right. And then a big overarching theme is that roots and exponents are inverse functions, just like how addition and subtraction are inverse functions. Multiplication and division are inverse functions. Also, roots and exponents are inverse functions. So, meaning, if I have the 4th root of 2 to the 4th power, root is 4, exponent is 4, they can cancel out, and that equals 2. All right, they just cancel out. Okay. And then flower power are fractional exponents. So if we have a fractional exponent, let's say we have 3 to the, let's say 2/3 power, okay? You can think of 2/3 as a flower in a pot, okay? This is the flower, or I should say the 2 is the flower, and then the 3 is the pot, right? And this is my fraction bar, the top of the pot. Since So 3 is in the pot. There's roots in here, right? For the flower, right? So it's the cube root. This would be the cube root of 3. And then flower power. The flower is the power, so it's to the second power. All right, so that's just a quick thing for that. And it will go over examples in today's class.